And another important highlight would be the lifetime. So in Rust, each reference has a lifetime, where the scope can be determined for which that reference is valid. So this additionally solves, it says addition, but it should be additionally, solves the problem with references that are no longer valid. And that's, again, another problem that you would face with C and C++. And you could be saying, well, Clarion, C++, it's used, it's clearly good, everyone's using it. Does it really matter that there's some issues with memory management? To which I would cordially reply to your inquisitive question, well, let's look at a real-life example. So Microsoft, huge company, it's made so many important apps, Power Apps to Skype. If you remember Skype, I remember it. Long-term relationships, not going to go into that. Okay, but the reason why I'm bringing this up is to point out to you that over the past 14 years, over 70% of errors from Microsoft and its federation of programs are due to poor memory management issues. It's a big reason why sometimes you could be running a Microsoft program and going, hey man, why isn't this working? What's going on? And for those of you who like to live on the edge, let's talk about safe Rust versus unsafe Rust. So you actually can write Rust in two different modes, safe Rust or unsafe. So safe Rust, what it does basically is that it'll add these restrictions for the programmer, which is another big problem that happens in production in C. And the benefit here is that these restrictions ensure that the code's going to work properly. All right, so you can write in that safe mode. Now, if you're feeling more dangerous, you can work in unsafe Rust as well. You can remove the restriction. You don't have to use those restrictions. And when you do that, of course, you increase your autonomy. And you could work with raw C-like pointers. But of course, then you're risking the code that it may break. So you can write with unsafe mode. You just need to be extra careful and take the time to measure that the code is really safe and working correctly. Now, how you would do this is by wrapping higher level abstractions so that you see that all the uses of the abstractions are safe. But let's save the tinkering and unfolding for the actual coding and examples portion of this course. However, please enjoy this lovely, cute little crawler over here that represents the unsafeness of unsafe Rust.